So now that we've got our basic model set up with some relations and some permissions, and we're computing those permissions in the most simplistic way possible, we can start to explore some of the operators offered by the SpiceDB schema language. These operators include the three algebra of sets operators that you might be used to. We have the union operator, which is represented by a plus sign, the intersection operator, represented by the ampersand, and an exclusion, represented by the minus sign. And to see how these work, we can actually use the playground itself to set up some examples. So the first thing I'm going to do is I'm going to add some relationships where we can set up a few more relationships for the common roles that we have. So I'm going to add reader 1, and then I'm going to do reader 2 and reader 3. And then I'll do an owner of the document as well. We'll do 2 owners. Owner 1 and owner 2. Whoops. Let's go ahead and change these to owner. So now we've got 3 readers and 2 owners of the document. And now we want to see what SpiceDB is going to load for each of those relations directly. Now we can ask SpiceDB to compute this for us. In the expected relations tab, we can go ahead and we can say document quarterly planning reader. This is YAML, so if we just define it to an empty list and ask it to regenerate, it'll tell us who the readers are. And then we can do owner, define it again as the empty list. So now we see we have our 2 owners and our 3 readers. But remember, in our schema, we wanted view to include not only readers, but also the owners. So for this, we can do a union. So if you remember, this we can do a union. So if you remember from algebra of sets, the union of 2 sets includes all members of both sets. So now we can ask SpiceDB who is allowed to view this document. So we can regenerate. And now we can see that we have all of the owners and all of the readers. Okay, but let's find a use case for the other operators as well. So that's union. Let's try intersection and exclusion. So exclusion is an easy one. We can often do like a banned user, so someone who's not allowed to use the platform at all. So for that, we can do reader plus owner. And then here we're going to take that union and we're going to subtract out those users who are banned. So banned. Okay. And now we can see if we regenerate, nothing happens. But if we go ahead and we add a user, let's add one of the readers to the banned list. So let's say that reader 1 is now banned. Now we should see that reader 1 disappears from the view. Reader 1 no longer has view permissions on the document quarterly planning. Okay, you'll notice that it still does the union first before subtracting out the banned. So the order of operations here are similar to the math order of operations. So the plus and the minus are on equal footing. So functionally what we've defined with parentheses would look like this. So it's the reader plus the owner minus banned. If we did instead owner minus banned first, because reader 1 is not a part of the owner group, and then we unioned that with reader, we should see that reader 1 pop right back in. Yep, so now they're back. So we'll just leave this in the clearest fashion possible. Right, and then so another way we could express the same thing, just for fun, would be that we could say that you are allowed to view if you are a reader, or you can otherwise edit. We won't do that because there's a slightly subtle difference there with the way that banned is taken into account. So we'll just put it back to what it was before. All right, and then the last operator here to demonstrate is the intersection operator. Common use case for the intersection operator would be for like a boundary, like a permissions boundary. We're going to use it to say that a user signed the terms of service, right? So we want this to apply to all users, readers and owners and band alike. So we're just going to wrap our existing computations, and then we're going to do an intersection with the signed terms of service. So I'll apply that to all of our permissions computations. Whoops. So now we've got uniform. And since so far there are no relationships, no users have signed the terms of service, we should see this go back to nothing. So view went to nothing, but reader and owner still, owner and reader. Oh, these are the owning and reading groups directly. So this is not edit and delete. So yeah, now we see that nobody has permissions to anything. And that's because when we intersect these sets, no matter how many users they have in them, with this set, which has no users, by definition, we're never going to get any users in our output set. So let's go ahead and have some users sign the terms of service. We'll have readers 1 and 2 sign the terms of service. Signed terms of service. Signed terms of service. And then let's have owner 1 also sign the terms of service. So now if we ask it to regenerate, we only get reader 1 or owner 2. We don't get reader 1 because reader 1 was banned. We get owner 1 in all of the places. So that's it for the basic algebra of sets operators. And they combine sort of exactly like you think they would. And there's one more operator that we'll get to in just the next video.